talk about is experiments and the basics of experiments. Okay, so you should have seen a lot of this knowledge already. This is kind of more of a refresher video than an actual teaching video. So here's the idea. We have explanatory variables and we have response variables. Your explanatory variable, that's typically, when you're doing a linear regression, that's your x variable. It's the variable we're using to cause a change in y. So we're messing with x. So this is kind of your treatments. What are we messing with to see a change in y or hope to see a change in y? That y variable is our response variable. That's the focus of the study, the outcome we are trying to explain. So the big idea with experiments is you have an x variable and a y variable that you might find a strong correlation with in a scatter plot. What we're doing with experiments is we're trying to develop a cause and effect. Just because there's correlation does not mean there's causation. That does not mean X causes Y. So our goal here as an experiment is to develop a well-designed experiment to actually see, does X in fact cause Y? Does our explanatory variable actually explain the type of response we get in our y variable, okay? So if you're going to do an experiment, there's three components that you need. You need randomization, you need replication, and you need control. If you have all three, you have a well-designed experiment. So when you're reading through scenarios, you want to look through those three components of a good experiment. Randomization, so what we want to do is the experimental units are assigned to treatments using chance process. So the big idea here of what we're trying to do with components of a good experiment is we're trying to eliminate all outside variables from having any effect on our results. We're really trying to eliminate all outside variables so we can really look at, does X cause Y? We don't want a confounding or a lurking variable, a variable that's on the outside that is the reason why we're seeing results in our response variables. We're trying to really take care of all the outside variables and only focus on, does X cause Y? Okay, so one way we could do that is randomization. So the experimental units are assigned to treatments using chance process. So meaning, depending on the design type you're doing, depending on what treatment you get is randomly assigned to you. I'm not going to pick, well, I guess you should get treatment A, you should get treatment B, and you should get treatment C. It's randomly assigned. You could use random number generators. You could flip coins. You could put your treatments in a hat on cards, mix them up, pull out a card, and say, all right, you're getting treatment A. Randomly assign who gets what treatment or what gets what treatment as far as your experimental units. The second thing is replication. That's using enough experimental units. That just means you want to do this experiment, multiple times or on multiple subjects or multiple experimental units. If I go out and try a fertilizer on my yard and I put it in one spot and say, voila, it worked, that's not good enough. Maybe that was just a really fertile part of the yard. You have no idea. So you want to do an experiment multiple times, replicate it, do it many times to make sure, yes, our results are in fact what we are going for, replication. So the way you see that is your experimental units, whether it's like plots of land that you're testing fertilizer or it's people, you want to make sure you're doing many plots of lands or you have many people subjects in the part of your experimental design. So you need replication. And then finally, control, which has a lot of subcategories in it. It's keeping other variables constant for all experimental units. So that kind of really hones in onto, let's make everything the same for everyone as much as possible, so no outside variables have any effect on our results. So keeping other variables constant for all experimental units. So all three of these, again, are going to help you try and establish, does X cause Y? Ways you can get control is one way you get a control group. Okay, you need some sort of group to as your baseline results to see if something works. If I'm trying to use a new drug for headaches and say, hey, it's much better than everyone else, then maybe I compare my new drug with like Tylenol. That's my baseline group, a control group. some sort of group that you're using for your baseline results to say, hey, are things actually different between my control and my actual treatment? Now, with your control group, your baseline group, they can have an active ingredient in their treatment, or it could be an inactive treatment, or it could be no treatment at all, okay? But you need some sort of baseline group. Ways that you can try and establish that baseline group and have a control group is a placebo, okay? Placebo. That is a treatment that has no active ingredients. No active ingredients. So they think they're receiving something, or they think something is happening, but really nothing is happening. So, like with a vaccine, the actual treatment may very well be a potential vaccine, but a placebo would be you get injected with what you believe is a vaccine, but there's no active ingredients in there that are actually going to protect you. Okay, it's a placebo, nothing is actually happening. Same with pills. You might get a pill that looks like, Tylenol or this, that, and the other, but as a placebo, that just means there's actually no drugs in it that are actually going to help you alleviate your headaches or whatever. Last thing under control is we have blinding and double blinding. Blinding is when one party or one part of the experience, they don't know what they're receiving. Okay, so if I'm trying out a potential pill, I don't know what type of treatment that I got. Did I get the super duper pill? Did I get a vitamin C pill? Did I get a vitamin D pill? Or did I get a placebo? I don't know. I'm completely blind to what I got. The reason for that is I don't want to be like, oh, I took Tylenol, so I know I should feel better. So now you start having if I knew what I took, is it really the pill that helped me? Or do I just believe the pill helped me, so I automatically yeah, I feel better because I knew I took Tylenol. So blinding eliminates that. I don't know if I took something or not, so that way we can get a little bit more real results. Double blinding is when both sides are unaware of what's going on. So not only the person receiving a treatment has no clue what they got, but the person administering it doesn't know what they're giving, okay? That's just another way to control so that the person administering, say, a pill or something like that, they don't tip off what sort of treatment they're giving. If I was giving people drinks of water versus vinegar, I mean, you can smell the difference, but let's just use it as a basic example. If I gave people water, I'm probably not going to expect them to say, hey, drink this. They're probably not going to facially, it's just water, right? Where if I gave someone a cup, I said, hey, drink this really quick, and it's vinegar, I'm probably going to watch them because they're probably going to make a really nasty face, right? So if I give them a cup of vinegar and I know I gave them a cup of vinegar, I'm probably like, ooh, I'm going to watch what you're doing. And then they're like, well, why is he looking at me? Am I about to receive something I shouldn't be? I don't want to tip them off, okay? So blinding is one part of the experience has no idea what treatment is happening. Double blinding means both sides. The people receiving treatments, the people administering treatments don't know either. That way there's no sort of bias or outside variables being like, well, I knew I put fertilizer on this plot of land, so I better see some grass growing here. Where if I knew I didn't put fertilizer over there, I'm going to be like, no, there's nothing growing. Definitely not, right? So it kind of disguises so there is no bias in your results, okay? So all three of these together make a good experiment. Your randomization, your replication, and your control. All three work together to really focus on and look at, does X cause Y, which that is the whole goal of experiments.